G'day. I'd like to have a quick chat with you about converting between units of length, area and volume. It's an area where a lot of errors are unfortunately made, but with a little bit of explanation, I think hopefully we can make a bit more sense of it. Now, I'm going to get you into a little bit of a hypothetical world here. I'm going to be talking about millimeters and centimeters, except the pictures are going to look a little bit different. So you should have a ruler, mandatory equipment. If you don't have a ruler, get one. Now, you should all know that a millimeter is one of those little things, smaller than the match head, if you've seen one of them, sort of, what's that, maybe about the thickness of the top of my pen here, right? While a centimeter is 10 of them. It's a bit bigger. So if I drew this and said, well, let's say that that's 1 millimeter, you then say that 1 centimeter should be 10 of them, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? And in turn, you would tell me that, well, 10 millimeters is 1 centimeter. But what about when we go to 2 dimensions? Instead of talking about length, we're going to talk about surfaces. If 1 millimeter looks like that, well, what would 1 millimeter squared look like? It's a surface now. It should look like this. 1 millimeter by 1 millimeter. That's a millimeter squared. Hence the idea of area. It's a surface. On the other hand, what would 1 centimeter squared look like? You should tell me, well, it's going to be 1 centimeter by 1 centimeter, isn't it? It's going to be quite big. And my question to you now, sir, is how many little 1 millimeter squared things are going to fit in 1 centimeter squared? How many of those little things are going to fit in here? Well, think there'll be 10 just along the top.
100?
Yeah, it'll be 100. 100 of these little things, and you could draw it. You could start drawing it. 2, 3, 4, 5, 6, 7, 8, 9, 10. And the same is going to go down here. 10 of them is going to fit down here. Right? Overall, when you draw that out, you're actually going to have 100 of those little millimeters squared in a centimeter squared. So it's no longer in length, it was only a conversion of 10. But in area, it becomes a conversion of 100. 100 millimeters squared is equal to 1 centimeter squared. And what about we take it a bit further? Oh, bird just popped on. Let's take it to volume. Let's try and present what 1 millimeter cubed would look like. We're in 3 dimensions now. Looks like one of those little counting blocks they used to have in primary school. All right? So it's 1 millimeter by 1 millimeter by 1 millimeter in each direction. What does that mean 1 centimeter cube is going to look like? Different. Right? 1 centimeter in each direction. So the question then is, how many of those little millimeter cube blocks are going to fit in here? It's going to be 10 along that way, 10 down that way, 10 back. There's a lot of little blocks going in there. Essentially, you end up with 1,000 millimeters cubed. Is 1 centimeter cubed. So indeed we're showing here, guys, that the conversions change. You cannot use the same conversions to go between units of length, units of area, and units of volume. This is just a distance. This is a surface. This is a space. This is a 3-dimensional space like the area around us. And you need to change your conversion rates depending on what you are dealing with. It's very important. Next up, I'm just going to put up a table to remind you of those conversions. And that's going to do for today. I'm going to leave it at that. I'm not going to go too far into this one today. All right. Now, I'm just going to quickly talk through what actually changes in your conversion rates when you go from length to area to volume. So first off, this is a diagram we're going to do for length. All right, we're going to look at length first. Now, first off, how many millimeters are in a centimetre? 10. How many centimetres are in a metre? 100. How many metres are in a kilometre? 1,000. Now, if I have something in millimetres and I'm changing it into centimetres, do I multiply or divide? I should divide. Whole rule goes like this. If I'm moving to a bigger unit, it'll be a smaller number. So in effect, that means all along the top here, whenever I move to a bigger unit, I'm going to get a smaller number. On the other hand, whenever I go to a smaller unit, I'm going to get a bigger number. Now that's the basis of converting between all of those units. All right, if I had 5 kilometres, I'd multiply it by 1,000 to get 5,000 metres. If I had 3.2 metres, I'd have to multiply that by 100 to get 320 centimetres. If I had 7.8 centimetres, I'd have to multiply that by 10 to get 78 millimetres. And the same in the other direction, right? If I had 34 millimetres, that would become 3.4 centimetres. If I had 780 centimetres, it would become 7.8 metres. If I had 540 metres, it would become 0.54 kilometres. Right, that's the basis of converting between units. Now I'm about to do a magic trick where I'm going to turn this diagram from a length diagram into an area diagram. Okay, so now all I've done is I've added 10 number 2s to the diagram and is now an area diagram. Right, these units here, they're no longer representing distances, which they did here. They're representing surfaces, okay? These are surfaces now. I represent my floor or my wall, or the surface on that book that's holding my phone in place, or the surface on this board. It's now a two-dimensional space. Now what we do in our unit conversions is what we multiply or divide by, it gets squared. That's it. Two-dimensional square the conversion. The units are squared, the conversions are squared. That's all. I'm now magically going to turn this into a volume diagram. And there we go. Again, all I've done, changed 10 numbers. And we've got a volume diagram. I meant to change that as well. This is now a volume diagram. Right? These units now represent a three-dimensional space. So millimetre cubed, that's a millimetre by a millimetre by a millimetre. So yeah, spaces represents how much air's in my room, how much grain I can get in the silo, how much water I can get in the tank, how much horrible sugary drink can I get in some drink that you guys are going to eat. The drink is just disgusting. I mean, I don't want to know that. But anyway, here we are, 3 dimensions. All we've changed is the units, so I know they represent a three-dimensional space, and when we convert units, we've got to cube them. That's it. Right? It just affects how you do the conversions. So, in summary, length is one-dimensional. In effect, they're to the power of 1, but you don't see the ones. Area is two-dimensional. You have 2's all through this diagram. Volume is three-dimensional. You have 3's all through this diagram. You can do it.